Hello everyone, welcome to the Zebra video tutorial. Today I'm introducing you how to use Zebra Embodied Carbon. So Zebra Embodied Carbon is an Excel workbook that helps you to estimate the embodied carbon, which is the greenhouse gas emission from the life cycle of a building material product. And when I'm speaking of life cycle, it means from the extraction of raw materials to the installation in construction and to the final reuse, recovery, and recycling at the end of the life of the building. So what Zebra does is using the embodied carbon factors of building materials you're planning to use to calculate the embodied carbon of the whole building throughout the life cycle. So here today, I'm leading you to go through the workbook to demonstrate how to input data and read the results. So on the first page here, you can find the written introduction to Zebra embodied carbon. On the right, you can find the first input parameter, which is the complexity level. So this is to determine proper settings for users from different levels. So complexity level 1 is designed mostly for beginners who don't have much knowledge and experience in embodied carbon calculation and in life cycle analysis. And complexity level 2 is for advanced users. And the complexity level 3 is the developer mode. So for the moment, I'm selecting complexity level 1 for demonstration. So having selected the complexity level, we can proceed to the next sheet, which is the building basics sheet. So here you need to input several parameters, basic parameters about the building details. So here, the first parameter is building names. This is only for reference. So for instance, we can here input building A. And then is the expected lifespan of the building, which means represent how many years the building is expected to last. Here we can input the passive house standard default lifespan, which is 60 years. And then is the treated floor area, which is typically around 90% of the gross internal area of the building, or 97% if you're treating a bungalow with no stairs. So here, we are treating with, for instance, a building with 200 square meters of gross internal area. So here, the treated floor area should be 180 square meter. And then is the land distance to landfill, which is the likely distance from the project site, from where the building locates, to landfill. So this is to calculate the embodied carbon from transporting the disposed building material to the landfill in the deconstruction of the building. So here we can input, for instance, 50 kilometer, which is a reasonable value. So if we turn the complexity level to 2 or above, we can actually see some more parameters on the right side. So these advanced parameters includes, for instance, the first one is emission factor, which is the factors for the embodied carbon emission for transportation in 4 different modes. This is to calculate the embodied carbon in stage A4, which is the transportation of manufactured material from the factory to the project site, and also for calculation of uh, stage C2, which is the transportation from at the end of the life cycle. So transportation for the disposed material from the project site to landfill. So, and then we have the location of manufacture. This is also to determine the carbon embodied carbon in in the transportation from factory, the location of manufacture to the project site. So we also have 4 classes, which is the local, national, which means manufactured in the UK, continental, which means that the products manufactured in Europe, and intercontinental, which means that products is manufactured somewhere else in the world. And finally, we have another two parameters linked to the treated floor area of the building. So the first one is emissions due to site activities, which is in the construction stage of the building, which is in life cycle stage A5A. So, and this is 28. And then we have another C1 factor, which is for to calculate the embodied carbon from deconstruction of the building. So this is building basics, and then we turn the complexity level back to 1 and proceed to the next sheet, which is the database. So this sheet contains the database, the inbuilt data of building materials in Zebra embodied carbon. So this data is coming together with the tool itself. So here in the green cells is the inbuilt data, and in the bottom of this sheet there are also some orange cells. This is for you to add your own new material and their carbon factors and other data. So this will be covered in another video tutorial. So I'm not discussing how to add a new material into Zebra today. So now we proceed to the next sheet. So this sheet is substructure. This you can see a series of sheets highlighted in red. These are the so-called building elements sheets. So to calculate embodied carbon, we need you to input the materials you want to use in this building element sheets. So to make the calculation. So the first building element sheet is substructure, which is essentially the foundation of the building. So here you need to input the materials you want to use in the foundation, in the substructure of your building. So for the moment, we say we want a reinforced concrete foundation. So what we need is concrete and rebar. So the first item should be concrete. We just put the description as concrete, and then we need to enter the material from a drop-down list. The first one is concrete, so we click the first one, and then we need to input the detailed type of the concrete, and we're planning to use it in situ, so it is in situ. Finally, we have a specification of what kind of concrete is situ concrete exactly we want to use. We can select C2530. And then is the lifespan of this material. So in this case, as it is used in the foundation, it's going to be the same lifespan with the entire building. So it is 60 years. And then is the location of manufacture, which means where this concrete, where this material is produced. And here we can select national, which means produced in the UK. And then finally, how much concrete we want to use. And for a building with around 200 square meter of gross internal area, it would be around to say 100 to 120 tons of concrete. So here we can put 120 ton. Okay, so here we see the quantity, which is 120 ton. And then we also need to input steel rebar, and using the same, following the same process. So material is steel, type is rebar, and specification is UK recycled, and lifespan is similarly 60 years, and location is also national. And then we need around 6 ton, I'll say 6 ton of rebar, so it will be 6,000 kilogram rebar. And now you can see here on the right side of this sheet, we have the output embodied carbon for two materials. And scrolling down, you can also see the total. which is 13K, 31K, 31 tons of embodied carbon. And then it is essentially the same input process in all the building element sheets. The only exception with different setting is the building services sheet. So here you can see a default estimation method, which is not based on you putting and inputting, adding new materials. It is a default method based on the treated floor area of the building. So here you select the service default estimation, and then there are 3 different levels of building services. For instance, the low level is only has simple boilers and radiators and uses natural ventilation. For a building with 180 square meter of treated floor area, this should be enough. But if you're dealing with a bigger building, you may need, for instance, the high service level, which uses full air conditioning, or maybe a medium level, which has some MVHR. So for the moment, we're here using the low service level. So you can see it just gives you the total embodied carbon estimation as 7 tons of carbon dioxide equivalent. So this is the building elements sheet for you to input new materials. If you again, if you put the complexity level to 2, you can see some slight differences in the data output. You can see the breakdown of embodied carbon by life cycle stages from A1 to D, and including the biogenic carbon. So you can also see the accounted for value here, which means how much embodied carbon is included in calculation in this case, because sometimes you may not have the carbon factors of a specific stage for your material. When this is absent in the database, when you don't have it, this will not be accounted for in the calculation. So this is data input sheet, and then you can see it's the same throughout on the red sheet. And so when you have inputted all the data required, you can go to the result sheet, which shows the results of the embodied carbon estimation from Zebra. So you can see this table showing the total embodied carbon of the building, and also the total intensity, which is the embodied carbon emission from per square meter of treated floor area in the building. You can also see the breakdown of embodied carbon by life cycle stages and by building elements. And here you can also see 2 pie charts illustrating the breakdown of embodied carbon by stages and by element. So this is a brief introduction to how to use Zebra embodied carbon. And in the next video, I'll talk about how to import data of new materials into Zebra and how to use them for calculation. Thank you very much.